Hi guys, so we're back and we're going to continue reviewing the 2024 Physics Regents. Except now we're going to do parts B2 and C, which are all short response questions. So let's get started. Questions 51 through 52. Planet Need has a mass of 6.5 times 10 to the 23rd kilograms and a radius of 2.96 times 10 to the 6 meters. The magnitude of the gravitational force of attraction exerted on the 5-kilogram object by Planet Need is 7.15 newtons when the object is located at a position 5.5 times 10 to the 6 meters from the center of need. Calculate the gravitational field strength of Planet Need at the position of the object. So, this question might seem confusing due to all the different components, but let's just focus on what we need. So the question is asking us for gravitational field strength of Planet Need on the object. If we look on our reference table, gravitational field strength is just G. And the equation for G is G equals Fg over m. And we can find these components in the question. So, Fg is the force due to gravity, and it says here that the magnitude of the gravitational force of attraction by Planet Need is 7.15 newtons. So we know that Fg is 7.15 newtons. And it also tells us what the mass is. It's exerted on a 5-kilogram object. So Rm is 5 kilograms. So we could just plug everything in. So G equals 7.15 newtons over 5 kilograms. And we're going to get 1.43 newtons over kilograms. (53 to 54). As shown in the diagram below, a toy car initially traveling at 1 meter per second uniformly accelerates to a speed of 4 meters per second as it travels down a 5-meter long slope. Calculate the time required for the toy car to travel the 5 meters from the top of the slope to the bottom. So, the first thing that we're going to do here is write out all our information that we know. So, we know that VI, or initial velocity, is 1 meter per second. We know that the final velocity, or VF, is 4 meters per second. We know that the distance is 5 meters, and we need to find time. So, let's look at all the kinematics equations on the reference table to see if we can use any of them. After we look through these, we can notice that all these equations that find time require acceleration. So we need to find acceleration first with the equation Vf squared equals Vi squared plus 2AD. And we could just plug in. So 4 squared equals 1 meters per second squared plus 2 times acceleration times 5 meters. And if we solve that out, we can get an acceleration of 1.5 meters per second squared. So now that we have acceleration, we can use the equation, let me use a different color here, Vf equals Vi plus At to find time. So let's just plug in again. So 4 meters per second equals 1 meters per second plus 1.5 meters per second squared times time. And once we solve out for time, we're going to get 2 seconds. And that is our answer. 55 through 56. Calculate the resistance of an incandescent light bulb that operates at 20 watts of power when connected to a 12-volt battery. So, the problem is giving us power and voltage, and it's just asking for resistance, because it tells us power is 20 watts, and that voltage is 12 volts. Now we just have to use the equation P equals V squared over R in order to find resistance, because that's the equation with all the components. So plug it in, 20 watts equals 12 volts squared over R, and we're going to get a resistance of 7.2 ohms. Base your answers to questions 57 through 59 on the information and graph below and on your knowledge of physics. The motion of a car traveling along a straight road is represented in the diagram below. Determine the average speed of the car from time equals 0 to time equals 8 seconds. So, this question is tricky if you don't remember how to calculate displacement with a velocity graph. Basically, you just have to find the area under the determined time. Since we need to find the average speed from 0 to 8 seconds, we find the area under the slope for that time. So we have to find everything in this little area. So what we could do here is we could split this up into a triangle and a rectangle. So I'm going to say that this here is area 1, and I'm going to color that in with red. This is area 1, and the rectangle here, that is area 2. And I'm going to color that in with blue. So now that we have these two little sections, we just need to find the areas of both of them and add it up. So A1, that is, since it's a triangle, we have to do 1/2, and that's times 8 times 6. And we're going to get 24. And for A2, since it's a rectangle, we don't have to multiply it by 1/2. We just do times 8 times 4. And that's 32. So when we add them up, 32 plus 24, we're going to get a total of 56 meters. So the displacement of the entire thing is 56 meters. Now we just use the equation V equals d over t, and we just plug it in. So velocity equals 56 meters. That's the total displacement over time, which was 8 seconds. And we're going to get an average speed of 7 meters per second. 58 through 59. Calculate the magnitude of the acceleration of the car from time equals 0 to time equals 8 seconds. So in order to calculate acceleration, we just use the equation A equals change in V over T. And since it's change in velocity, we're just going to do A equals V2 minus V1 over T. And we just plug in. So V2 is 10 meters per second, and V1 is 4 meters per second. So 10 meters per second minus 4 meters per second over 8 seconds. That's 6 over 8. So we're going to get an acceleration of 0.75 meters per second squared. 60. A light ray is traveling through a transparent medium at a speed of 1.75 times 10 to the 8th meters per second. Determine the absolute index of refraction of this medium for this light ray. So, in order to find the index of refraction, we're just going to use the equation N equals C over V. Because we already have the velocity, it tells us that right here. And speed of light is a constant, and speed of light is C, by the way. So we just plug everything in. So N equals 3 times 10 to the 8th, meters per second over 1.75 times 10 to the 8th meters per second. And we're going to get an N of 1.71. 61. As shown in the diagram below, a ray of light traveling through medium X is incident upon the surface of medium Y. The absolute index of refraction of medium Y is greater than the absolute index of refraction of medium X. On the diagram in your answer booklet, use a straight edge to draw a ray that might represent the path of the light in medium Y. So I'm just going to do this question here. But it tells us that the index of refraction for medium Y is greater than that of medium X. Something that you're going to need to remember is that the bigger the index of refraction is, so bigger index of refraction, that means that the ray will be closer to the normal. So when we're drawing it out like this, it's going to be something like this. Do you see how the ray gets closer to the normal? When the index of refraction is bigger, it's closer to the normal. And on the opposite end, if the index of refraction is smaller, it's further away from the normal line. 62 to 63. A tungsten wire has a cross-sectional area of 5.03 times 10 to the negative 7th meter squared and has a resistance of 1.21 times 10 to the negative 2 ohm when operated at 20 degrees Celsius. Calculate the length of this wire. So, in this question, they give us all the components we need, so we just have to use the equation resistance equals resistivity times length over cross-sectional area. So it says here resistance is 1.21 times 10 to the negative 2 ohm, and that equals resistivity of tungsten, and we can find that on our reference table, and that is going to be 5.6 times 10 to the negative 8th ohm times meters. We're finding length, and that goes all over cross-sectional area, which is 5.03 times 10 to the negative 7th meter squared. So once we solve this out, we're going to get a length of 0.109 meters, or 1.09 times 10 to the negative 1 meter. 64 to 65. As shown in the diagram below, a block is hanging motionless from a vertical spring, having caused the spring to elongate from its unstretched length of 0.2 meters to a length of 0.5 meter. The spring has a spring constant of 250 newtons per meter. Calculate the magnitude of the force exerted by the block on the spring. So, for this question, we need to find force, and we have to use the equation Fs equals Kx. So, it already tells us that the spring constant, or the K, is equal to 250 newtons per meter. However, we need to find the spring length by subtracting the length of the stretched spring and the unstretched spring. So, 0.5 meters minus 0.2 meters, that equals 0.3 meters, which is our x value. So now we could just plug it in. So Fs equals 250 newtons per meter times 0.3 meters, and once we solve that out, we're going to get a force of 75 newtons. Now we're on to part C. Base your answers to questions 66 through 70 on the information and data table below. In an experiment, a resistor is connected to a source of varying potential difference. A voltmeter and an ammeter are included in the circuit so that the current can be measured at different potential difference settings. The data table below shows the potential differences and currents measured. Using the information in the data table, construct a graph on the grid in your answer booklet following the directions below. So for question 66, we have to plot the data points for current versus potential difference. So I'm going to switch over to the answer booklet to show you guys what it should look like. So I just finished plotting it, and this is what it should look like. This is a very simple question. And for 67, it asks us to draw the line of best fit. So the line of best fit is pretty much just a line that goes through most of the points. So it should just look something like this. So now we're back to the regular booklet, and we're going to do questions 68 to 69. So calculate the slope of the line. So in order to calculate slope, we have to use the equation slope equals change in y over change in x, which is also just y2 minus y1 over x2 minus x1. And you can pick whatever points you want, but for this, I'm just going to pick the easiest points, which is the first point and the last point. So now we just plug it in. So our y-axis is current, and our x-axis is potential difference. So 0.898 amps minus 0 amps over 8 volts minus 0 volts, which is just 0.98 amps over 8 volts, which equals 0.12 amps over volts. That's our answer. Now, 70. Determine the resistance of the resistor. So, in order to determine the resistance, we're just going to pick a random point and use the equation R equals V over I. So, I'm just going to pick the last points again and plug it in. So, resistance equals 8 volts over 0.98 amps. And once you calculate that, you're going to get 8.2 ohms. Base your answers to questions 71 through 75 on the information and diagram below. An alpha particle with a charge of +2 elementary charges is moving toward the two oppositely charged parallel plates, as shown in the diagram below. The magnitude of the electric field strength between the plates is 5 times 10 to the 4th newtons per coulomb. Determine the magnitude of the charge of an alpha particle in coulombs. So, it tells us that the alpha particle has a charge of +2 elementary charges. So we just need to look at the reference table to see what the charge of an elementary charge is. After looking, we can see that one elementary charge is equal to 1.6 times 10 to the negative 19th coulombs. So all we have to do is multiply that by 2, since it's 2 elementary charges, and we're going to get 3.2 times 10 to the negative 19th coulombs. And that is the magnitude of the alpha particle. 72. On the diagram in your answer booklet, draw at least 3 field lines to show the direction of the electric field in the space between the charged plates. So, the direction of the electric field is going to look something like this. And let me explain why in 1 second. Sorry, the lines are a little bit slanted. It shouldn't be slanted, but basically, the electric field between plates will have straight lines in the middle, moving from the positive plate to the negative plate. It always goes from positive to negative. See how the arrow is moving from positive to negative? That is the key factor. And 73 is asking what is the direction of the electrostatic force exerted on the alpha particle as it passes between the plates. Once again, that is towards the negative plate. It's always going towards the negative from the positive. 74 to 75. Calculate the magnitude of the electrostatic force exerted on the alpha particle by the electric field as the alpha particle passes through the electric field. So, this problem, they already gave us the charge of the particle and the magnitude of the electric field strength, so we can solve for electrostatic force by using the equation E equals Fe over Q. So we have E, that's 5 times 10 to the, I have to check up here. 5 times 10 to the 4th newtons per coulomb, and that is equal to Fe over 3.2 times 10 to the negative 19 coulombs. So once we solve this out, we're going to get Fe equals 1.6 times 10 to the negative 14th newtons. Base your answers to questions 76 through 80 on the information below and on your knowledge of physics. 2 students investigate transverse waves using a long stretch spring. One student holds one end of the spring stationary while the other student produces 12 waves per every 4 seconds. The waves have a uniform amplitude of 0.2 meter and the distance between 2 adjacent crests is 0.4 meter. 76 to 77. On the diagram below in your answer booklet, draw at least one complete wave produced in the spring. So I'm going to switch over to my answer booklet now. So I just finished drawing the wave and it should look something like this. So in the question, it said that 2 adjacent crests were equal to 0.4 meters, and when it says 2 adjacent crests, that just means the length of one wave. So the length of one wave is 0.4 meters, which is why this spans 0.4 meters, and the amplitude is 0.2 meters, which means the displacement is going to be like this. It goes up 0.2 and it goes down 0.2. So now we're back at the regular packet, and for question 78, we have to solve for frequency. So remember, frequency is the number of waves that pass within a certain amount of time. And it tells us here that 12 waves pass every 4 seconds. So to find frequency, we just have to do 12 divided by 4. And that's going to give us 3, which is 3 hertz. 79 through 78. Calculate the speed of the waves. So, in order to find the speed of the waves, we're just going to use the equation velocity equals frequency times wavelength. And we just plug in. So, V equals frequency, 3 hertz, times wavelength, which was 0.4 meters. And we're going to get a velocity of 1.2 meters per second. Base your answers to questions 81 through 85 on the information below. Alpha particles are stable decay products of many nuclear disintegrations. An alpha particle consists of 2 protons and 2 neutrons and has a mass of 6.644 times 10 to the negative 27th kilogram. When the individual masses of 2 protons and 2 neutrons are added, the sum is 6.695 times 10 to the negative 27th kilogram. The difference between the mass of an alpha particle and the total mass of its 4 individual component particles is called the mass defect. 81. Determine the mass defect in kilograms when 2 protons and 2 neutrons combine to form an alpha particle. So, as it just explained in the question, the mass defect is just the mass that the particle loses. So in order to find that out, we just have to subtract the 2 masses. So the individual masses is bigger than the alpha particle mass. So we're going to do 6.695 times 10 to the negative 27th kilogram minus 6.644 times 10 to the negative 27th kilogram. And that is going to equal 5.1 times 10 to the negative 29th kilogram. 82 to 83. Calculate the total amount of energy in joules that would result in the complete conversion of this mass defect to energy. So, in order to find the energy of the mass defect, we just have to use one of our energy equations. And the equation with all the necessary components, if you look on the reference table, is E equals mc squared. So we just plug it in. So E equals mass, our mass defect, we just got that, 5.1 times 10 to the negative 29th kilogram. C is a constant, that is the speed of light, which is 3 times 10 to the 8th meters per second. And you have to square that. And after you solve that out, you're going to get 4.6 times 10 to the negative 12th joules. 84. Determine the total amount of energy that would result from the complete conversion of this mass defect to energy in mega electron volts. So, now we have to take the energy that we got in the last question and convert the unit into mega EV. In order to do this, we have to go from joules, we have to start at joules, and then go to electron volts. And from electron volts, we have to go to mega electron volts. And if we look at the first page of our reference table, we can find all these conversions. So 1 EV is equal to 1.6 times 10 to the negative 19th joules. So we have to divide our energy by this value in order to get the units to EV, because 1 EV is much smaller than 1 joule. So our value in EV will be much bigger. So if we do 4.6 times 10 to the negative 12th divided by 1.6 times 10 to the negative 19th, we're going to get 2.9 times 10 to the 10 to the 7th EV. So it went from a negative exponent to a positive exponent, showing how much bigger a joule is than an EV. So since an EV is smaller, there's going to be more of it. So now that we have our value in EV, we have to turn that into mega EV. So once again, when you look on the reference table, you'll see that something that is mega is 10 to the 6 times bigger than the normal unit. So since we're going from EV to mega EV, we have to divide this by 10 to the 6th. And once again, since the mega unit is way bigger than the regular unit, our value is going to get smaller now. So 2.9 times 10 to the 7th divided by 10 to the 6th. And that is just going to turn it into 29 mega EV. 85. What fundamental interaction is primarily responsible for holding protons and neutrons together in an alpha particle? So this fundamental interaction is strong force. It's always going to be strong force. Anything dealing with combining or separating particles is strong force, because no other force can deal with these things except for the strongest of them, obviously. So that is the last question of this Regents. I hope you guys understood this review. Thank you so much for watching and have a good day.